Okay, we're continuing on. We're still on worksheet 1, chapter 1. And this is problem 2, which reads, a car goes from 0 to 55 miles per hour in 16 seconds. What is its acceleration in G's? Well, I suppose I should tell you now that 1 G is going to be equal to 9.8 meters per second. And this is a conversion problem. So we will be converting from 55 miles per hour to G's. So let's go ahead and do that. In order to do that, we need to multiply our value by an expression that won't change the value, yet it will change our units. So once again, we have 55 mph, which is, we can rewrite to 55 miles per hour. And I need to get meters per second square, and then in 16 seconds. So V is that, T, this is delta V because it starts from 0. Delta T equals 16 seconds. So I can't really calculate my acceleration yet because I cannot mix hours with seconds. So I'm going to need to go ahead and, let me go ahead and convert this to a meters per second velocity. So I happen to know that 1609 meters equals 1 mile. So I'm going to go ahead and convert those miles into meters. I'm going to go ahead and put 1609 meters over 1 mile. And I know this is just what we call an expression for unity. It's the same as 1. It's like having 1 pizza divided by 8 slices. The top and the bottom are exactly the same value, although they have different names, if you will. So I'm going to go ahead and do that. And now I need to get these hours converted into seconds. So I'm going to go ahead and put 1 hour here. And that will, these hours will cross out, right? And then 1 hour is 3,600 seconds. All right, and if you do the math on this, if you go ahead and multiply the numerators and the denominators and divide through, you're going to get 24.6 meters per second. Now we want to go ahead and convert that into G's. Well, first we have to get a value for the acceleration. So A is going to be equal to delta V divided by delta T. And delta V is V final minus V initial. T is T final minus T initial. So this is going to be equal to 24.6 meters per second minus 0, it starts from rest, divided by 16 seconds minus 0. And so that value is going to give us 1.53 meters per second squared. So A is going to be 1.53 meters per second squared. And now to convert that into G's, I know 1 G from up here equals 9.8 meters per second squared. So I'm going to go ahead and set up an expression for unity, which is just the same as 1. That doesn't look like 1, but I can multiply my value by it and not change the value. So I'm going to have 1 G on top and then 9.8 meters per second squared in the denominator. And I'll get 0.156 G's. So that's my answer. And this is a conversion problem. It's a good thing to practice if you're a little stiff on converting values. Very good way to practice this. Okay. Okay, we're still on worksheet 1. And we're on problem 3. And problem 3 reads, a man jumps off a 50-meter cliff. Neglecting air resistance, how fast is he going just before he hits the ground? All right, so in order to solve this, we have to realize that when we are falling towards the ground on Earth, we have an acceleration due to gravity, A due to gravity, and we call this G, and its value is 9.8 meters per second squared. And it points straight down. All right. So we need to know this value in order to solve this. So we have the displacement, delta x, equals 50 meters. I'm going to go ahead and use our displacement equation, which, if I can remind you, x final equals x initial plus v naught t plus 1/2 a t squared. And our x final is going to be 50 meters. We're just going to go ahead and make our coordinate system like this. We're going to call this 0 and this 50 meters. And we're going to go ahead and use this downward direction as a positive direction. That's not the conventional. We would usually use that as a negative direction. But I'll go ahead and use it as positive, 9.8 meters per second squared. I could call this negative and could call that negative, and we would get the same value. And this is going to be equal to 0. We're calling this 0. Plus he jumps off. We'll call it, he steps off. So he's got a 0 initial velocity plus 1/2 times 9.8 meters per second. Oh, wait. I'm solving for how fast is he going? My bad. Not the time. All right, let me go ahead and erase, and I'll. You would use that if you wanted to solve for the time. Okay, so now for that, we can go ahead and use our simple equation, our simple velocity equation. We're going to say v final equals v initial plus acceleration times time. So we got v final. Oh, we don't know time. We're going to go ahead and do it this way. Yes, let's go ahead and solve for time, and then we'll solve for it. We could do it many ways, but we'll go ahead and do it this way. This is how the solution has it on your worksheet solution. So I'll go ahead and use this. All right. Okay, so we've got 50 meters equals 0 plus 0 plus 1/2 times 9.8 meters per second squared times t squared. And solving for t, I'm going to get 100 meters. I multiply through by 2 on both sides, divided by 9.8 meters per second squared under the radical, and that's going to equal to t. And t is going to be equal to 3.2 seconds. Now, it's a simple matter of using this equation to solve for my final velocity. So Bf equals 0 plus 9.8 meters per second squared times 3.2 seconds. And that's going to give me 31.3 meters per second. 31.3 meters per second. And that's our final answer for this guy, 31.3 meters per second.